Hello students, welcome to Anne's classes. Let's do sets chapter 6, exercise 6a. Page number 74, question 6. List the elements of the following sets. So here in the first one we have this x is such that x square minus 2x minus 3 is equal to 0. So we have another quadratic equation here. So let's write that down. So that is x square minus 2x minus 3 is equal to 0. We have to solve this. We have to find the value of x by solving this quadratic equation. Now look at this quadratic equation. Now look at this number, the third term here, that is minus 3. That means you have to think of two numbers that when you multiply you get minus 3. So here let's look at that. Now suppose I say what are the numbers that give us 3 first of all. 1 into 3 is 3. But this will give us only 3. How do we get minus 3? For that we have to look at the middle term also. Take only the numerical coefficient, that is the number, minus 2. So here, let me write minus 2. Now, I have two numbers here, 1 and 3. Nothing else will give me minus 3. Nothing else will give me 3. Now, these numbers I have to add to get minus 2. So, how do I do that? So, if I say 1 plus 3, I will not get minus 2. I will get 4. Now, how do I make this minus 2? I can make this minus 2 by turning plus 3 into minus 3. So let's do that and see. Now if I change this to minus 3, now what will I get? My answer will be minus 2. So 1 minus 3 is minus 2. Similarly, the same minus 3, if I put it here also, now if I make this minus 3 and now multiply, what do I get? 1 into minus 3 is minus 3. So the two numbers that I have are 1 and minus 3. If I take these two numbers, then if I multiply, I will get minus 3. If I add, I will get minus 2. So I'm going to split my middle term into 1 and minus 3. So let's write that. So this is x squared plus 1x. I'm taking it from here. 1x minus 3x. Okay. So 1x minus 3x will give me minus 2x. And when I multiply 1 into minus 3, I will get minus 3. So let me write that also. So this is equal to 0. Now in the next step, we have to bring out a common term. So before that, we will take the first two terms and the second two terms to look for the common term. So now we're going to look for a common term here. Now here x and x. Here x square is there, here there is 1x, that means x is common. So I can bring out x and put the rest within brackets. So if I remove 1x from here, there is 1x left, which I can put here. So there is 1x left, then I have a plus sign. Now if I look at this 1x here, I already have an x here. So all I have to do is bring that 1 down. So this becomes 1. So this is now x plus 1. Now let's continue. So this part we have put it this way, x into x plus 1. Now this part also we are going to do it that way, but we have to keep in mind that what we get within bracket should be the same. It should be x plus 1. So how do we do it? Let's try. So let's take this minus 1 and put it here. And now look for the common term here. Here I have 3x and here I have 3. So 3 is common. So let's bring the 3 out and in brackets let's put, now I'm going to put x plus 1. That is, if I remove minus 3 from this, what is left is only x. So I'm going to put x. And now I have removed minus 3 from there and I put it here. So here I have to just put plus 1. Because if I multiply minus 3 into 1, I will get minus 3. So I have removed what is common. I put the rest inside and this is equal to 0. So now what is common here? This side we have x plus 1 common, here also x plus 1 common. So I can take that out as the first factor. So that is x plus 1. Then what is left here? Here I have x minus 3. So I have x minus 3 that I can write it down here. So that is x minus 3 and both are equal to 0. Now when you have factors like this which are equal to 0, it means that the first factor is equal to 0 and the second factor is also equal to 0. So here this expression x plus 1 is equal to 0. So from this we can find the value of x. X will be equal to 0 minus 1. So x is equal to minus 1. So I found the first term. Now let's take the second one, that is x minus 3, and do it the same way. X minus 3 is equal to 0. That means x is equal to 0 plus 3. So x is equal to 3. So now I have found x to be minus 1 and x to be 3. Now what does the question say? List the elements of this set. So the elements of this set, let me write it here. The elements of this set will now be minus 1 and 3. We have found that out here. X is minus 1 and x is 3. So the elements are minus 1 and 3. Question 2. X is such that x is equal to 2y plus 5. So let's keep this in mind. X is going to be 2y plus 5. So we need to know what y is. So here y belongs to natural numbers. And look at this part. So here it says y is, now let's read this carefully, y is greater than and equal to 2. And less than 6. Okay, so first thing we need to do is get all the elements of y. So let's write the elements of y. So here it says clearly y is greater than 2, but it's also equal to 2. That means we can start from 2. So let's start the elements of y from 2. So y is equal to 2, but it's also less than 6. So write all the numbers less than 6 after 2. So 2, 3, 4 and 5. So this is y. Y is 2, 3, 4 or 5. Now we have to look at this equation. It says x is 2y plus 5. So it says x is equal to 2y plus 5. So that means x is 2, 3, 4 and 5. So when x is 2, when y is 2, when y is 2, what is the value of x? X will be 2y means 2 into y, and y here is 2. 2 into 2 plus 5. So 2 twos are 4 plus 5 is 9. Now we took only 2. Next we're going to say y is equal to 3. So let's take that. So when y is equal to 3, what is the value of x? X is equal to, now look at this, 2y plus 5. That means 2 into y. So let's write that 2 into 3, because this time y is 3 plus 5. So 2 threes are 6. 6 plus 5 is 11. Then we're going to consider y to be the next number, which is 4. So when y is 4, what will the value of x be? X will be equal to, now remember the formula, 2y plus 5. So 2 into y, and this time y is 4 plus 5. 2 fours are 8. 8 plus 5 is 13. So we have taken y to be 2, 3 and 4. Now let's take y to be 5. So when y is 5, what is the value of x? X will be 2y plus 5. 2y plus 5. So that is 2 into y, and y is 5 plus 5. So 2 into 5 is 10. 10 plus 5 is 15. So these are the elements of the set 9, 11, 13 and 15. So let's write down the elements of the set. So the answer is the elements of the set are 9, 11, 13 and 15. So this is our answer, the elements of the set. Question 3, x is such that x is a factor of 24. So now first thing we need to find out all the factors of 24. So what are the numbers that multiply to give you 24? 1 into 24 is 24. Then we have 2 into 12. 2 12s are 24. Then go to 3. 3 8s are 24. Then let's go to 4. 4 6s are 24. That's it. Nothing else will give us 24. So what are all the factors of 24? Factors of 24 are all these numbers that we have here, that is 1, 2, 3, 4, 6, 8, 12 and 24. So let's write that. Factors are 1, 2, 3, 4, 6, 8, 12 and 24. So now the question is, what are the elements of the set? We have to write the elements of the set. So the answer is the same. So let's write the answer. The elements of the set are 1, 2, 3, 4, 6, 8, 12 and 24. So all the factors of 24 are the elements of this set. Question 4, x is such that x belongs to z. And what does z stand for? Integers. and x square is less than and equal to 4. So now we need to find the value of x in such a way that when you square it, the answer should be less than and equal to 4. So let's consider x to be, now remember these are integers. So let's first begin with 0. Suppose we say x is equal to 0. Then in that case, what about x square? X square will be 0 square, which is 0. Then let's consider x to be 1. In that case, x square will be 1 square and 1 square is 1. So we have taken 0 and 1. Now let's consider x to be 2. X square is equal to 2 square. So 2 2s are 4. So now we have got 4. That means if I go beyond 2, I will get a number greater than 4. So I will stop with x is equal to 2, which is 4. At the same time, remember, these are integers. That means I can take negative numbers also. That means I have 1 here. Let me take minus 1 and see. So x is equal to, if x is equal to minus 1, then x square will be minus 1 square. And minus 1 square is minus into minus is plus, 1 into 1 is 1. And again, if I take x is equal to minus 2, so x square will be minus 2 square. And minus into minus is plus, 2 2s are 4. So here also can you see I'm getting 4. That means if x is 0 or 1 or 2 or minus 1 or minus 2, I will get the square of it to be less than or equal to 4. That means the elements of my set are all these numbers. So I can write my answer this way. The elements are, I can start with the negative numbers, minus 1, minus 2. Okay, so I have written this minus 1, minus 2. Now let me take 0, 0 and 1 and 2. So 1 and 2. So these are all the elements of this set. So this is my answer. Question 5. X is such that 3x minus 2 is less than and equal to 10. This is the first part that we need to solve. At the same time, keeping in mind that x belongs to natural numbers. So let's solve this. 3x minus 2 is less than and equal to 10. So here we can write this as 3x is less than and equal to 10 plus 2. Because I've taken this minus 2 to the other side, it's become plus 2. That means 3x is less than and equal to 12. So x is less than and equal to 12 by 3. That means x is less than and equal to 12 divided by 3 is 4. So we have solved this part. I hope you've understood this. 3x is less than and equal to 12. So to find x, I'm taking 3 to the other side. It's become division. Now when you divide 12 by 3, you get 4. So now we know what the values of x are going to be. It's going to be less than and equal to 4. And here it says x belongs to natural numbers. So we begin from 1. So what are all the numbers now? So x will be equal to 1, 2, 3 and 4 because here it says less than and equal to 4. So this is our answer. These are the elements of set 5. Question 6. X is such that 4 minus 2x is greater than minus 6 and x belongs to integers. So this is what we need to solve first. So let's write it down. So 4 minus 2x is greater than minus 6. This is again an inequation because we don't have an equal to sign. So here we're going to solve for x. So how do we do it? Just like the previous question, we're going to say minus 2x is greater than minus 6 minus 4 because we have taken this 4 to the other side, it's become minus 4. Then we continue and say minus 2x is greater than minus 10. Now we're going to find the value of x. X is greater than, now we'll write this side first, minus 10 and here it is multiplication. So when it goes to the other side, it becomes division, minus 2. Now in equation, when you divide by a negative number, this sign will change. So now this is greater than and it will now become lesser than. The sign of the inequation will change when it is divided by a negative number. So now what does this become? So now we can say that x is less than, here let's Simplify this. So here we have cancelled the minus signs and 2 5s are 10. That means x is less than 5. So now we can find all the elements of the set. So what will our answer be? It will all be elements, numbers that are less than 5. And since they are integers, it will even take up the negative numbers. So less than 5 means we begin with 4, isn't it? 4, then 3, 2, 1, 0. Even the negative numbers, minus 1, minus 2, minus 3. Now this goes on. This goes on. So this is my answer. These are the elements of this set. Question 7. State which of the following sets are finite and which are infinite. So that means if the set has limited number of elements, we call it a finite set. And if it has an unlimited number of elements, we call it an infinite set. So that means we need to find out the elements of this set. So let's find out the elements of this set. Let's read it. X is such that X belongs to integers. So remember, these are integers. It can have negative numbers, positive numbers and 0, and X is less than 10. So what are all the numbers less than 10? 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0, minus 1, minus 2, minus 3 because it belongs to integers, all the integers. So here let's rewrite the elements of this set here. So A is equal to, now let's begin with say minus 5. Minus 5, okay, and that means then I can write minus 4, minus 3, minus 2, minus 1, 0, 1 and I can go on up to less than 10 up to 9. So this end, the numbers are ending because it says less than 10, so I know what it is. But at the other end, now here at this end, here we started with minus 5, but it does not say that it is greater than minus 5. It says any number less than 10. That means I can still continue. There are many more numbers that I can continue with. So I'm going to put dots here to show that this continues. Okay, so here we're getting numbers less than 10. So up to 9, this end is finite. But whereas this end is going on, that means this is an infinite set. So the answer to this is an infinite set because it goes on. Question 3, B is equal to X is such that X belongs to whole numbers and 5x minus 3 is less than and equal to 20. So we have to solve for X first, keeping in mind that X belongs to whole numbers. So let's write that 5x minus 3 is less than and equal to 20. Again, this is an inequation. So we're going to solve for X using that 5x is less than and equal to 20 plus 3 because I've taken 3 to the other side. So 5x is less than and equal to 23. Now we can find the value of x. So 5x is less than and equal to 23 divided by 5. So now let's divide that and see. So 23, let's divide it by 5. 5 fours are 20. Now we have minus 3. So I'm going to continue my division by putting a point, carrying that point up. Now put a 0, bring the 0 down. I have 30. 5 sixes are 30. So now I've got the value of x to be 4.6. So let's write that x is less than and equal to 4.6. So we have found the value of x. Now let's go back to this part. It says x belongs to whole numbers. So think of all the whole numbers less than 4.6. So all the whole numbers less than 4.6 will be 0 because it's a whole number, 1, 2, 3 and 4 also. So let's write the elements of this set here. So that is B will be equal to, now let's write all the elements, 0 because it's a whole number, 1, 2, 3 and 4 because 4.6 is greater than 4 and here it says x is less than and equal to 4.6, but 4.6 is not a whole number, so we stop with 4. So these are the elements of set B. So now can you see I have 1, 2, 3, 4, 5 elements very clearly. I don't have dots here, I don't have dots here to show that it's going on indefinitely. So here I have a limited number of elements. So this is a finite set. So we can write the answer that this is a finite set. Question 3, P is equal to y is such that y is equal to 3x minus 2. And here x belongs to natural numbers, and also one more point here, x is greater than 5. So first of all, what are the numbers greater than 5? So let's see, x is equal to greater than 5 means 6, 7, 8 and so on. This itself tells us this is an infinite set, but we need to work out this. Okay, that is y is equal to 3x minus 2. So if we take the statement 3x minus 2, why is this? Isn't it? Y is equal to 3x minus 2 in the place of x. Now if we put 6, so when x is equal to 6, then y will be equal to 3 into 6 minus 2, which is 3 6 are 18 minus 2, which is 16. So the first number is 16. Now next we have taken 6, isn't it? Let's take 7. So when x is equal to 7, y will be 3x, that is 3 into 7 minus 2. 3 sevens are 21 minus 2 is 19. That is when x is 7. Now let's take x to be 8. So if when x is equal to 8, then y will be 3 into 8 minus 2, which is 3 8s are 24 minus 2 is 23. So now we have 23. So that means that's 22. 24 minus 2 is 22. Now if we continue, this goes on and on, isn't it? So that means the elements of this set P will be 16, 19, 22 and so on. And the question is this a finite or an infinite set? So as you can see, since the dots are there, that means this is an infinite set. Because this goes on, there is no end to it, there are no limited numbers, so this is an infinite set. Question 4, m is equal to x is such that x is equal to 3 by n and n belongs to whole numbers, and now let's learn to read this correctly. N is greater than 6 but less than and equal to 15. N is greater than 6 but less than and equal to 15. So what are the values of n? So n is greater than 6 means we start with 7, 8 and remember it says less than and equal to 15. So you have to go up to 15. 9, 10, 11, 12, 13, 14 and 15. So this part we've got what n is. Now let's look at this part. X is equal to 3 by n. So x is equal to 3 by n. So that means let's start by taking n to be 7. So when n is equal to 7, then x is equal to 3 by n, that means 3 by 7. When n is equal to 8, x will be equal to 3 by n, which is 3 by 8. When n is equal to 9, x is equal to 3 by 9. When n is equal to 10, x is equal to 3 by 10. It continues like that up to 15. So when n is equal to 11, x is equal to 3 by 11. N is equal to 12, x is equal to 3 by 12. Then n is equal to 13. We have to go up to 15. X is equal to 3 by 13. And when n is equal to 14, x will be equal to 3 by 14. And when n is equal to 15, x will be equal to 3 by 15. So now we have all the elements of set M. So let's write down all the elements of set M. That will be starting from here. 3 by 7, 3 by 8, 3 by 9, 3 by 10 and all these. So let's write down the elements. So that will be 3 by 7, 3 by 8, 3 by 9, 3 by 11, 12, 3 by 13, 3 by 14 and 3 by 15. So now as you can see, there are a definite number of elements. There are no dots on either side. So there are limited number of elements. So this is a finite set. So our answer is this is a finite set. Question 8. Find which of the following sets are singleton sets. Now what is the meaning of singleton sets? Singleton sets are sets which have only one element inside, only a single element inside it. Such sets are called singleton sets. So the first question, the set of points of intersection of two non-parallel straight lines on the same plane. That is, if you have two non-parallel straight lines, how many points of intersection will they have? Now, first of all, what are parallel lines? Parallel lines are two lines like this. They will never meet, so they don't have a point of intersection. Now, if you take two non-parallel lines, that is, if I just take one line like this, and I take another line which will meet it, because non-parallel lines will meet. So this line has met here at this point, isn't it? So this is called the point of intersection of these two lines. These are non-parallel, so they have met at a point. Now, how many points of intersection are there? There's only one point of intersection. So this is a singleton set. So the answer is, it is a singleton set. Second question here, a is equal to x is such that 7x minus 3 is equal to 11. So if we solve this, we will know the elements of set A. So here let's solve this. 7x minus 3 is equal to 11. So now we need to find the value first of 7x. 7x will be equal to 11 plus 3. So 7x is equal to 14. So what is the value of x? X will be equal to 14 by 7, which is 2. That means x is equal to 2. So what is the element of this set? The element of this set is just 2. That means this is also a singleton set. So this is a singleton set. So we can write that singleton set. Question 3. B is equal to y is such that 2y plus 1 is less than 3 and y belongs to whole numbers. So first let's work out this. That is 2y plus 1 is less than 3. This is an inequation. So let's work this out. So 2y will be less than 3 minus 1. So now we can find the value of 2y. 2y is 3 minus 1 is 2. So what will the value of y be? Y will be less than 2 divided by 2, which is equal to 1. Now, y is less than 1. What does this mean? Let's look at the second part. Y belongs to whole numbers. So if y is less than 1, which is the number, the whole number, which is less than 1? The whole number that is less than 1 is 0. So the element of set B is 0. So now how many elements are there in the set? There is only one element. So this is also a singleton set. So we can write that this is also a singleton set. Question 9. Find which of the following sets are empty. So in this, the first one, the set of points of intersection of two parallel lines. So let's see the set. And if the set has points of intersection of two parallel lines, then we say that set is not an empty set. Okay, but if it doesn't have any points of intersection, then we say it's an empty set. So let's take two parallel lines. So we have one parallel line here and one parallel line here. These are two parallel lines. Now, one very unique point about the parallel lines is the distance between the two lines will always remain the same. That means how much ever you extend them, they will never meet. Whether it's this side or this side, both sides, they will never meet. That means they will never intersect at a point. So in that case, the set of points of intersection of two parallel lines is going to be empty. There are no points of intersection here. So this set is an empty set. We don't even have even one point of intersection. So the answer here is empty set. So this is an empty set. Now the next one, set x is such that x belongs to natural numbers. So the first point let's underline. And what does this part say? X is greater than 5 but less than and equal to 6. So this point is also important. So let's write that. X is greater than 5. So greater than 5 means 6, 7, 8, 9, 10. But it's also lesser than and equal to 6. So this set A, the element will be only 6. Because if you look at this element, this is greater than 5, isn't it? But it's also equal to 6. It's less than 6, but it's also equal to 6. So that means there is one element in this set. So set A is not an empty set. So we can write that not an empty set. Set A is not an empty set. Question 3. Set B is equal to x is such that x square plus 4 is equal to 0. So we need to solve this, and x is the element of x belongs to natural numbers. So let's solve this. X square plus 4 is equal to 0. That means to find the value of x, we say 0 minus 4. So x is equal to, now 0 minus 4 is minus 4. So x square is minus 4. So x will be the square root of minus 4. Now the square root of minus 4 is not a natural number. It's not a natural number. So since it's not a natural number, this set B will not have any element in it. Why? Because it says the element inside should be a natural number, and we don't have a natural number. So B is empty. That means this is an empty set. So we can write that empty set. The fourth one, C is equal to even numbers between 6 and 10. So first let's write down all the numbers between 6 and 10. So 7, 8 and 9. These are the numbers between 6 and 10. And the question says we have to choose only the even numbers. And here, as you can see, the only even number is 8. So this is the only even number. That means our set C will have the element 8 inside. So the question is, find which set is empty, and the question 4, set C is not an empty set because it has one element in it. So not an empty set. Question 5. Set D is prime numbers between 7 and 11. So between 7 and 11, let's write down all the numbers first. Between 7 and 11, we have 8, 9 and 10. Now among these, which of these is a prime number? As you can see, none of these are prime numbers. That means set D does not have any element in it because we don't have any prime number between 7 and 11. So this is an empty set. So set D is an empty set. We will stop with that for now, children. In our next video, we will continue with the remaining questions. Thank you, children.